Hi guys, Mrs. Pesic here. It is time for our video lesson on logarithms. There's actually going to be two. This first one is the beginning of section 7.4. We're going to look at evaluating logarithms. And in the second video, we'll look at some special logarithms and how to evaluate them on the calculator and how to graph them. So right now, what I need you to be doing is following along with the examples and be working them out on your video guided notes. All right, so section 7.4 is evaluate logarithms and graph logarithmic functions. First of all, some cool applications of logarithms. First of all, like the pH level in water. All right, the pH level in water is determined using logarithms, and there's a couple other interesting applications. Tornadoes and earthquakes both could be uh, related to the topic of logarithms. So tornadoes, earthquakes. All right, so let's get started and talk about what logarithms are. All right, first of all, you know that 2 to the third is equal to 8, and 2 to the fourth is equal to 16. But for what value of x does 2 to the x equal 11? Well, we can write that question as a logarithmic equation, and we would write that like this. We would say x equals log to the base 2 of 11. All right? And that is read, as I said, x is the log to the base 2 of 11. All right, one thing I want you to remember is that logarithms are exponents. That's very important. Highlight that, write that somewhere. When you're confused about what's a logarithm, just remember it's an exponent. All right, and we can say the logarithm of y with base b is written this way, log to the base b of y, or log of y to the base b. All right, so one thing you do need to understand is that b raised to the x power is equal to y if and only if log to the base b of y is equal to x. So in other words, what we are going to be doing is going back and forth between exponential form and logarithmic form. This one right here is in exponential form, and this one over here is in logarithmic form. All right, so let's practice a few. Again, b to the x equaling y is an exponent form. Log to the base b of y equaling x is the same exact equation, just written in logarithmic form. So let's start off with this first one. We have 2 cubed equals 8. 2 to the third power equals 8. So if we want to write that in logarithmic form, you are basically going to be filling in the base of what equals what. So remember, logarithms are exponents. So the exponent over here is 3. So that means the log is 3. So the 3 has to go right here. And what's the base over here? I see the base is 2. And remember, we say log to the base what? So in this case, it's log to the base 2. The log to the base 2 of what? Well, that's going to be the only thing left here is 8. So we're going to pop 8 right here. So it's log to the base 2 of 8 is equal to 3. Means the exact same thing as 2 to the third equals 8. Let's try another one. 4 to the second power equals 16. So we're going to rewrite that one in logarithmic form. So we want log to the base what of what equals what. Keep in mind that this right here, this number is the logarithm. We're saying the logarithm is this. And so what we want to do is plug in that exponent, because logarithms are exponents. So that's the 2 is going to go right here. And what's the base? Base is 4. That's going to go right here. And we're going to say log to the base 4 of 16 is equal to 2. All right, let's try another one. Hope you're getting all these down in your video guided notes. Okay, So let's try this one. 3 to the fourth is equal to 81. So we want log to the base something of something equals something. Well, what is the log? The log is the exponent. That means this exponent right here goes right here. And the base was 3. So the 3 goes here. And log to the base 3 of 81 is going to give us 4. What this is really saying is 3 raised to what power gives me 81? Well, 3 to the fourth power gives me 81. All right, let's try going the other direction. So if I give you one in logarithmic form, can you rewrite it in exponential form? So my example is log to the base 9 of 3 equals 1/2. So how will we rewrite that in exponential form? Well, what's the base? I even said log, when we read it, we say it log to the base 9, right, of 3. So my base is 9 raised to what power? Well, the power is the exponent, and logarithms are exponents. So that means this has got to be our exponent right here. So it's going to be 9 to the 1/2 equals what's left? 3. Is 9 raised to the 1/2 equal to 3? Well, you know what rational exponents mean, so just to make sure we're understanding this, that's the same thing as saying square root of 9 is equal to 3, because 9 to the 1/2 and square root of 9 mean the same thing. All right, let's try another one. How about this one? Log to the base 6 of 1 is equal to 0. Well, again, we want some base raised to some power equaling something. Well, what's the base? Well, we even said log to the base 6. So that's going to be your base. It's going to go right here. All right, so that means we want to put the 6 right here. Raised to what power? Remember, that's our exponent. Logarithms are exponents. 0 is the logarithm here, because 0 equals the log. So that means that is going to be the exponent. That's going to go right here. So this is going to be 6 to the 0 equals 1. And that makes sense because anything to the 0 power is equal to 1. All right, let's take a look at some interesting ones. Can you write this one in exponential form? Log to the base star of moon equals cloud. So if we want to rewrite that one in exponential form, that means we want something raised to the something equaling something. Can you fill the boxes? Well, what's the base? We said log to the base star, so we want to get the star right there. Raised to the exponent. What's our exponent? The exponent is the log, and the log here is cloud. So we need cloud here equals what? Well, it's going to have to equal moon. All right. Let's try one more of those going the other direction. Can you rewrite this in logarithmic form? We have pound sign raised to the swirly equals dollar sign. So if we're going to rewrite that in log form, then we want to write this as log to the base something of something equals something. Can you fill in the boxes? Well, what's our base? Our base is right here, and so that is going to be showing up right here. So that means we want the pound sign right there. The exponent is here, but logarithms are exponents, so this log is going to be that exponent right there. So that means we want the swirly to go right there, and the dollar sign is going to fit right here. All right, so we'll say log to the base pound sign of dollar sign equals swirly. All right, that's the whole idea here, is just to make sure you are comfortable moving things around, shifting them from exponential form to logarithmic form. or logarithmic form to exponential form. All right, now let's try evaluating some logarithms. Let's try this one. Log to the base 10 of 100. What this means is 10 raised to what power, right, is equal to 100. That's the translation of this. This says 10 raised to what power is going to give us 100. Well, what's that going to be? 2. 10 squared is equal to 100, so our answer to this one is 2. All right, try this one. Log to the base 3 of 27. What's that going to equal? Well, I want you to be thinking about this as 3 raised to what power gives me 27? Well, 3 times 3 times 3 gives me 27, so this answer is going to have to be 3, because 3 raised to this power is going to give me this. So our answer for this problem is 3. All right, let's try another one. How about log to the base 5 of 625? Again, we're saying 5 raised to what power gives us 625? And you know from your handy dandy help sheet that that would be 4. So our answer here is going to be 4. Log to the base 5 of 625 is 4. Let's try one more of these. Maybe a couple more than that. Log to the base 8 of 2. That's basically saying 8 raised to what power is equal to 2. Well, this one might be a little tricky, but I want you to think about the handy dandy, and you know that 8 right here really is a power of 2 already. I could write it as 2 to the third, correct? So I'm really saying 2 to the third raised to what power is going to equal 2, and this over on this side is 2 to the first. So that means the problem that we really have is 2 to the 3 times something, I'll say 3 box, is equal to 2 to the first. If your bases are the same, then that means the exponents have to be the same. That means we can write a little equation that says 3 box equals 1 and solve for box by dividing both sides by 3. So the answer to our question is 1/3. What's log to the base 8 of 2? It's going to be 1/3. I would need 1/3 right here. Doesn't that make sense? Because we say cubed root of 8 is equal to 2. All right, and that's what 8 to the 1/3 means. Okay, so now let's try this next one. Slide it down a little bit. This is log to the base 7 of 1 is going to equal what? If we have log to the base 7 of 1, we're saying 7 raised to what power is equal to 1? Well, you know that we would have to have a 0 here. 7 raised to the 0 is equal to 1. So our answer is 0. And how about log to the base 5 of 5? That's saying 5 raised to what power is equal to 5? Well, you know that's going to be 1. So log to the base 5 of 5 is equal to 1. That leads us to 2 properties of logarithms based on these last 2 examples. And the properties look like this. One says log to the base b of 1 is always going to equal 0. That's just like this example right here. Log to the base 7 of 1 was equal to 0. This is basically saying b raised to the 0 is equal to 1. So there's our first property of logarithms. Log to the base b of 1 is equal to 0. And one more property, and that is log to the base b of b is going to always equal what? If you have the same base that you're taking, if you're going to have the same number in both places, b here and a b here, then that is going to be log to the base b of b is always going to be 1. That's just like this example right here. So that is our second property here, that log to the base b of b is equal to 1. Okay, so you've watched this first video on logarithms, and I hope that you have got your video guided notes all filled out. And this story of logarithms will continue in our second video guided notes. All right, see you soon.